Welcome to day 66. Today, we're going to pull back the curtain on a really powerful technique in natural language processing, Latent Dirichlet Allocation, or as it's more commonly known, LDA. So, imagine you're faced with a mountain of text. We're talking customer reviews, news articles, maybe scientific papers. How do you possibly figure out the main topics hidden inside all of that without manually reading every single word? It sounds impossible, right? Well, this is the exact problem that topic modeling is designed to solve. And by the end of our short time here, you're going to have a solid intuition for how an algorithm can look at a finished document and essentially work backward to figure out the original recipe of topics that likely created it.
To really get a feel for that recipe, the key is to forget about analyzing text for a second. Instead, let's just imagine how a document might be created in the first place.
You see, LDA is what's known as a generative model. What that really means is that it's built on a foundational story, kind of a thought experiment, about how a whole collection of documents comes into being. So the story goes something like this. First, to write a document, you decide on its high-level recipe. Let's say it's going to be about 70% astronomy and 30% immigration. Then, for every single word you want to write, you first pick one of those topics based on that 70-30 mix. If you land on astronomy, you then choose a word from a list of astronomy words like space, planet, or star. If you land on immigration, you pull from a totally different list with words like border or policy. And you just repeat this process for every single word in the document.
Now here's the really clever part. LDA makes this bold assumption that every document you give it was generated by this exact quirky process. So the algorithm's entire job is to look at the final, messy text and reverse engineer everything to find those original topic recipes and the word list for each topic.
Okay, so how does an algorithm actually pull off this reverse engineering feat? Well, it all comes down to the magic of probability. The formal name, Latent Dirichlet Allocation, actually gives us a few clues. First, it's a probabilistic model, which means it deals in likelihoods, not certainties. It treats documents as mixtures of topics, that's our recipe, and it sees topics as distributions of words, those are our vocabulary lists. Now, a really crucial simplification that LDA makes is what's called the bag of words assumption. It just completely ignores grammar, sentence structure, and word order. To the algorithm, the sentence, "the cat sat on the mat," is exactly the same as "Matt cat the sat on the." All it cares about are which words are present and how often they show up together. The algorithm works by iterating through every word and making an educated guess. For each word, it asks two things. First, looking at just this document, which topics seem most likely to be here? And second, looking across all the documents, which topic does this particular word seem to belong to most often? It has to balance these two probabilities. It assigns the word to a topic, then moves on, refining all of its assignments with each pass. After thousands of these cycles, the topic assignments finally stabilize, and that's when the hidden structure is revealed. Now, this isn't just some abstract, theoretical model. It's an absolute workhorse in the industry, and I can almost guarantee you've interacted with systems that use it. A classic example is the New York Times recommendation system. When you read an article, LDA is working behind the scenes, modeling that article as a mixture of topics. It then suggests other articles that have a similar topic recipe. It's an incredible way to connect you to relevant content at a massive scale, all without needing a human to manually tag anything. And this same idea applies all over the place. It's used for automatically organizing huge document collections, analyzing the main themes in thousands of customer reviews, and even identifying emerging trends in science by clustering research papers together. So if you remember just one thing from today, let it be this.
LDA is an unsupervised model. You don't tell it the answers ahead of time. You just give it the text, and its whole job is to reverse engineer those hidden topic recipes that it assumes were used to generate the documents in the first place.
It's a really powerful way to find the signal in the noise. Which, of course, leaves us with a question for you. What hidden structures are just waiting to be discovered in your own data?